Mac operating system setup, install the Flutter SDK. In this video, we're going to install the Flutter SDK, add Flutter to the path environment variable, and use Flutter Doctor to detect issues. In your browser, navigate to flutter.io and click on the Get Started link. Select Install on Mac OS and scroll down to get the Flutter SDK. Click on the zip file download link. The download is going to require 700 megabytes of disk space and will take a few minutes to download depending on your download speed. Open the Spotlight search and search for Terminal. Open Preferences to change the font size or the background. Create a directory and call it Development by typing mkdir development and hit Enter. Mkdir is the terminal command that allows you to create a directory. By default, any folders that we create will be placed in the home directory. Navigate to this folder by typing cd development and hit Enter. cd is the terminal command that allows you to change directories. Copy the unzip command from the Flutter website and paste it in the terminal window. Hit Enter. This will extract the Flutter SDK from the Downloads directory into the one that we created. Open a Finder window and hit Command plus Shift plus H to go to the home directory. In that directory, you will find the development directory that you created. Inside of this directory, we have a directory called Flutter. Inside of this directory is the Flutter framework. If we click on Bin and then Cache, you will find a directory that contains the Dart SDK. Since this is a new programming environment, we need to create a bash profile. To create files with terminal, we use the touch command. Type touch space tilde / dot bash underscore profile followed by the enter key. The tilde key is directly under escape on a standard US keyboard. This command will create a hidden text file named bash underscore profile in the home folder. To open the file with terminal, type open space tilde / dot bash underscore profile and hit enter. This opens the file in the default text editor. Type export space path in uppercase equals / users / codechamp / development / flutter / bin $ path in uppercase. Substitute codechamp with your username. So for example, if your username is John Smith, your path should be users / John Smith / development / flutter / bin $ and path in uppercase. Save the file and close the editor. Also close the terminal window. Reopen the terminal window and type export space $ path and hit enter. If you see a line with development / flutter / bin, you have done everything correctly. Type Flutter Doctor to detect any issues with your Flutter installation. Flutter can be upgraded by typing Flutter Upgrade, but I will show you when to upgrade at a later stage. The summary tells us about the 5 issues we will need to address in the upcoming videos. In the next video, we will install Android Studio and XCode. Mac operating system setup, install Android Studio and XCode. In this video, we're going to install Android Studio, then we're going to create an Android emulator, and we'll install XCode. In your browser, go to developer.android.com/studio. Click on the Download Android Studio button. Read the licensing agreement and check the box when you are finished. Click on the Download Android Studio for Mac button. This should take a couple of minutes depending on your connection speed. Open the Downloads folder and open the Android Studio DMG file. In the window that pops up, drag the Android Studio icon into the Applications directory. Open the Applications directory and double-click on Android Studio to open the application. A window should pop up asking if you would like to import settings. Since this is a new installation, select Do Not Import Settings and click OK. You are next presented with the Android Studio Setup Wizard. Click Next to begin. Choose the standard installation type and hit Next. And then hit Finish, and Android Studio will start downloading components. During the download process, it will ask you for your administrator password. This allows the installation of the Hardware Accelerated Execution Manager. Click Finish when the download is complete. Start a new Android Studio project. Keep the default name, leave the other settings, and hit Next. Select the phone and tablet checkbox with API 15 and hit Next. On the Configure Activity screen, leave the defaults and hit Next. Once the components are installed, hit Finish. The purpose of this project is to allow us to create an Android emulator. Alternatively, you could use a physical Android device. Sometimes, when you first create an app after a fresh install, you get an error message. To fix the error, click the link in the message log to install Build Tools 27.0.3 and sync the project. Click on the AVD Manager and select Create Virtual Device. Select the Nexus 4 and hit Next. Give the AVD a custom name or leave the name as the default and hit Finish. Close the window. Hit the green play button to run the app on the emulator that you just created. If you did everything correctly, you should see Hello World on the screen. Open Spotlight Search, type App Store and hit Enter. In the App Store's search box, type XCode and hit Enter. Click on XCode. Click Get and then Install App. Depending on how your system is set up, it will ask you for your App Store ID and password. Click Sign In when you are done. Go to the Purchase tab and click Install next to XCode. This installation process takes a while, so you can use this time to grab some coffee. In your browser, go to brew.sh and copy the command to install Homebrew. Paste the command in the terminal and hit Enter. Terminal will ask you for your password during the install. Run Flutter Doctor and hit Enter to detect issues with your Flutter installation. Now that Brew is installed, we are able to address these issues in upcoming videos. In the next video, you will install IntelliJ and build your first app. Mac operating system setup. Install IntelliJ and create your first app. In this video, we are going to fix issues with the Flutter installation. Install IntelliJ and build and run your first app. In the last video, we installed the Homebrew Package Manager to help us install the missing packages. Install libmobile device by pasting the command into terminal and hitting enter. Once completed, scroll to the top and copy the command for iDevice installer. Paste it in the terminal and hit enter. Do the same for iOS deploy. Copy and run the command to install iOS deploy. Copy and run the command to install CocoaPods. Copy and run the command to set up pods. To accept the Android licenses, run Flutter Doctor space -- Android licenses. Type Y and hit enter to review the licenses. In your browser, go to jetbrains.com/idea. Click on the download link and download the community version. In your downloads folder, double-click on IdealC, and in the window that pops up, drag the IntelliJ icon into the Applications folder. In the Applications folder, double-click on IntelliJ. Do not import settings. Scroll down to accept the privacy policy. For data sharing, you can choose to send or don't send usage statistics. You can choose Darkula or Light Theme. For the Keymat scheme, choose I have never used IDEA and hit Next. Keep defaults for the launcher script. Keep defaults for the featured plugins, then start IntelliJ. In the Configure menu, select Plugins in the search box, type Dart, and click Search in Repositories. Select the Dart language plugin and hit Install. In the search box, type Flutter. Select the Flutter language plugin and hit Install. Click Accept because the Flutter plugin is a third-party plugin. Close the window and restart IntelliJ. Run Flutter Doctor to identify any issues with the Flutter installation. We have one issue. There are no connected devices available. Open the simulator by typing open space -a space simulator and hit enter. Run Flutter Doctor again to check for issues. If you did everything correctly, there should be no issues. It's not necessary to install Dart and Flutter plugins for Android Studio because we will be using IntelliJ. Create a new IntelliJ project. Click on Dart. The top of the window indicates the location of the Dart SDK. We need to direct this path to the location of the Dart SDK, which was installed when we installed the Flutter SDK. Pointing to this location gives us access to sample content. Select the console application and hit Next. Give the project a name. Leave the project location as default and hit Enter. The red section is the main editor. This is where you will write your code. The green section is where you will manage your project files. The blue section is where you will receive error messages or warnings, and you also have access to the terminal. Let's delete the code on line 4, and immediately we are told that the import statement on line 1 is not being used. So let's delete that as well. We are left with the main function. It serves as an entry point into our app. On line 3, type void before main. Delete the code between parentheses. Type print followed by opening and closing parentheses and a semicolon. In the parentheses, type Hello World in double quotes. Click the green play button to run the app. Hello World is printed to the console. Congratulations, you are now a developer. In the next video, we'll install the Flutter SDK on Windows. Windows Operating System Setup. Install the Flutter SDK. In this video, we are going to install Git, install the Flutter SDK, and add Flutter to the path environment variable. In your browser, go to flutter.io and click on the Get Started button. Click Install on Windows and click on Git for Windows. This will take you to another website which downloads Git to your computer. Double-click on the file we just downloaded to run the installer. Read the information and click Next. Select a destination location. Leave the default settings for the components. Select Vim as the default editor to be used with Git and hit Next. We want to use Git from the Windows command prompt. We're going to use the OpenSSL library, so make sure that it is selected and hit Next. Keep the default setting for configuring line ending conversions. Use the default setting for configuring the terminal emulator to use with Git Bash. Keep the default settings for configuring extra options and hit Install. When the installation is complete, select Launch Git Bash and hit Finish. Pin Git Bash to the taskbar. Right-click on the title bar and select Options to customize the user interface. Return to the browser and download the Flutter SDK zip file. When the download is finished, extract the files into the download folder. Open the extracted file, right-click, and cut the Flutter folder. Go to your C drive and create a new folder called SRC. Open this folder and paste the Flutter folder inside. Open the folder and locate the file flutter_console.bat. Double-click this file to open the Flutter console. This will allow you to run Flutter commands in the Flutter console, but you will be unable to run commands in the PowerShell or command prompt. While we are in the Flutter console, we can type Flutter Doctor followed by the Enter key, and this will identify any issues with our Flutter installation. Go to the Control panel and click on User Accounts. Click on User Accounts again, and on the left, click Change My Environment Variables. Under User Variables, click on Path and hit Edit. In the window that pops up, hit New, and we're going to type the location of the Flutter SDK that we placed in the SRC folder. Type C:/SRC/Flutter/bin. Hit OK and reboot your computer. Open Command Prompt and run Flutter Doctor. We have 3 issues, and we'll address these in the upcoming videos. In the next video, we'll be installing Android Studio on Windows. Windows Operating System Setup. Install Android Studio. In this video, we're going to install Android Studio, create an Android emulator with AVD Manager, and create an Android emulator with Genymotion. In your browser, perform a Google search for Android Studio and select the first link in the search results. Click the download link to begin. Agree with the terms and conditions and download Android Studio. In the Downloads folder, open the setup file. We're going to leave all the checkboxes as they are and install Android Studio with all the default settings. Select Do Not Import Settings and click OK to complete the installation. On the Welcome screen, click Next. We want a standard installation. Choose your preferred theme and click Finish when you're done. We have an error. It says HaxM installation failed, and the reason why this happened was because my computer has an old AMD CPU. Don't be alarmed. There's a fix for this problem. However, if you have an Intel CPU, you should be fine. Click Finish and let's start a new Android Studio project to set up the emulator. Create a project with all the default settings. Leave the name as it is. Select API 15 and choose an empty activity. Android Studio will install the required components and click Finish when done. It seems like we have another error. We need to install Build Tools 27.0.3 and sync the project. In the upper right corner, click on AVD Manager and click the button to create a virtual device. Select the Nexus 4. This is where it gets tricky. If you have an Intel CPU, you can download any of the recommended images. The higher the API level, the more features you will gain access to as a developer. The lower the API level, the more compatible your app will be with older devices. If you have an AMD CPU, you need to click on the tab that says Other Images. Select KitKat and hit Download. Now that we have the image, we can create our emulator. Name the emulator KitKat and hit Finish. To start the emulator, hit the green play button to start and the red button to stop. However, this emulator has been running for a while, and to be honest, it's painfully slow, but we can use Genymotion, which is much faster. In your browser, go to genymotion.com/fun-zone and click on Download Genymotion Personal Edition. You will need to create an account, which is free. If you don't have VirtualBox installed, you will need to download the version that has VirtualBox. For VirtualBox to work, you will have to enable virtualization in your computer's BIOS. Start Genymotion and log in with your username and password. Click the plus button to create a new virtual device. Select Android 4.4.4 and for the device model, select Nexus 4. Click Next, and if you wish, you can give your emulator a custom name. Start the emulator. Reopen the Android Studio project from before. Click the green play button in Android Studio to run the project on an emulator. Select the Genymotion emulator that we just created. If you did everything correctly, you should see Hello World displayed on the emulator's screen. In the next video, you will install IntelliJ and build your first app. Windows Operating System Setup. Install IntelliJ and build your first app. In this video, we're going to install IntelliJ and build your first app. In your browser, go to jetbrains.com/idea, click on the download link, and select the community version. In your Downloads folder, double-click on IdealC to begin the installation. The installation process is going to be similar to Android Studio because IntelliJ is actually the base for Android Studio. Set up IntelliJ to be associated with .java, .groovy, and .kt. This would allow you to open files with these extensions without using the default text editor. Run IntelliJ and choose Do Not Import Settings. Choose your preferred UI theme and leave the defaults for the next two screens. On the Welcome screen, click the Configure wheel and choose Plugins. Search for Dart, and you will find that you need to search in the repositories. Install the plugin and search for Flutter. Click the Install button and a privacy notice will appear because it's a third-party plugin. Click Accept and click Restart IntelliJ. Minimize IntelliJ and open Genymotion to start the emulator. Open the command prompt and type Flutter Doctor and hit Enter. Do not worry about the missing plugins for Android Studio. We'll be using IntelliJ to learn Dart basics and develop Flutter apps. You'll notice that there are no issues and we're ready to begin coding. Select Create a new IntelliJ project. Click on Dart. The top of the window indicates the location of the Dart SDK. We need to direct this path to the location of the Dart SDK, which was installed when we installed the Flutter SDK. Pointing to this location gives us access to sample content. Select the console application and hit Next. Give the project a name, leave the project location as default, and hit Finish. The sections outlined with green and blue rectangles are known as tool windows. The red section is the editor main window. This is where you will write your code. The green tool window is where you will manage project files. The blue rectangle is where you will receive messages regarding the code, such as error messages or warnings. You also have access to the terminal. At this point, don't worry about the to-do section. It will be covered later. Let's delete the code on line 4, and immediately we are told that the import statement on line 1 is not being used, so let's delete that as well. We're left with the main function. It serves as an entry point into our app. In object-oriented programming, a function is a block of statements that perform a particular task when executed. On line 3, type void before main. Delete the code between parentheses. Type print followed by opening and closing parentheses and a semicolon. In the parentheses, type hello world in double quotes. Click the green play button to run the app. Hello world is displayed to the console. Congratulations, you are now a developer. Congrats again on making it to the end of day 1. In the next video, we'll be looking at Dart variables. Variables, data types, and control flow. Introduction to variables and data types. In this video, we're going to define a variable, learn about the different types of variables or data types, create variables, and print some information to the screen. Variables are like building blocks because they hold the program together. They store information that relates to a program. Open the Dart file that we created in the last section. Let's give ourselves some room by hiding the project window. If there is a line of code that you don't want to be executed, you can type 2 forward slashes, and this creates a single line comment. Developers use comments like notes. This is very helpful when they come back to it later. Let's go on a new line and create a comment that says creating variables. Variable names should be descriptive, written in lower camel case. They must not contain spaces or special characters, but underscores and the $sign are allowed. Variable names cannot begin with a number, but they can contain a number. Names cannot be keywords. If we type var first name and we don't set a value, this is called declaring a variable. If we set the value to Victor, we have declared and initialized our variable. We say initialize because the initial value of our variable is Victor. The same way that we put different things into a box, we can put different values in a variable. Let's create another variable. Actually, let's speak like programmers. Declare and initialize a variable to store your age. Var age is equal to 33. What do you notice about the first line of code and the second line? You should have noticed that each line of code ends with a semicolon. The first name variable is placed in double quotes. The age variable has no quotes. The reason for this is that these variables contain different types of information. The first variable contains a string of characters and it's called a string. For this warning that pops up, just click OK. After first name has been initialized with a string, only strings can be placed in that variable. The age variable has been initialized with an integer, and only integers can be placed inside the age variable. If we try to place an integer inside of the first name variable, we get an error, and if we try to place a string inside of the age variable, we also get an error. We only use the keyword var when we are creating a variable for the first time. Let's comment out the last two lines of code. We can update the value of the first name variable to Steve, and we can update the age variable to 26. If we want to be more precise, we can use the string keyword to create a variable to store your last name, and we can use the int keyword to store your current age. If we try to create a variable that has been declared before, this will cause an error. So let's not do that. You can use single quotes or double quotes for strings. The int keyword is short for integer, and this can be used to store whole numbers. If we wanted to store decimal numbers, we would use the double keyword. Let's create a variable to store your height. I am 181.61 centimeters tall. If we are unsure of the type of number, we can use num. For example, num miles to Bridgetown is equal to 17. But if we want to be more precise, we should use int or double. Booleans are used to store true and false values. We can create a Boolean using the keyword bool. Bool is sunny is equal to true. Bool is hungry is equal to false. Let's print all of these variables to the screen by using the print function. If you did everything correctly, all this information should be displayed in the console. In the next video, we will be looking at string concatenation and string interpolation. String concatenation and string interpolation. In this video, we're going to demonstrate string concatenation, demonstrate string interpolation, and perform a few functions on strings. String concatenation involves joining strings together end to end. If we join foot and ball, we get football. String interpolation involves the use of placeholders in a string literal. These placeholders are variables and they're replaced with the values they contain at runtime. Open the playground Dart file that we worked on in the last video. We can easily hide all of this code in a collapsed multi-line comment. To begin a multi-line comment, you type a / and an asterisk. We close it with an asterisk followed by a /. We can then collapse it by clicking the minus sign on the margin. Let's create a single line comment and start typing concatenation. Create a string to store your name. Create a string to store a greeting. Let's say hello. To concatenate strings, all we have to do is add them together using the plus sign. Create a new variable and let's call this one full greeting that stores the result of the addition. Now let's see if we can print full greeting to the screen, but we first need to call the print function. You'll notice that the words are joined together with no space. If we want to add a space, we need to add a string that contains a space. So if we run this again, you'll notice that there is a space between the words. Create a comment for string interpolation. You can still use the keyword var to create strings. Create a variable named SomeString and say that today Victor is going to the store to buy hot dogs. Update the name variable to Steve. Replace the word Victor in the string with the actual variable. But in order to do this, we need to use the $. Print SomeString and see what happens. What do you think would happen if we moved the updated name variable and placed it before declaring and initializing SomeString? If we run the program, it is going to print Steve. The way how code works is that it starts at line 1 and then it goes to 2 and 3 and then all the lines that follow. Create a variable for the groceries and replace the word hot dog with groceries. Update the name to Michael and print to the screen. Typing a period after a string allows you to see all the functions that you can perform on a string. We want the toUpperCase function, and this allows us to convert all the letters in a string to uppercase. If we print SomeString to the screen, we can see that all the letters have been converted to uppercase. If we try to print the name variable, we can see that it has not changed because strings are reference types. When we perform that function, you are dealing with a reference to name. The toLowerCase function can be used to convert all the letters to lowercase. In the next video, we're going to be looking at arithmetic operators and the equality operator. Arithmetic operators, equality operators, and relational operators. In this video, we're going to be looking at arithmetic operators, equality operators, relational operators, and perform some operations. All the code from the last video has been placed in a collapsible comment. Go on a new line and create a variable and set the value to 2. var a is equal to 2. Go on another line and create a variable and set the value to 3. var b is equal to 3. Print the sum of a and b. Print a plus b. Update a to be a plus 2. A is equal to a plus 2. Now print a. What do you notice? The value of a has changed, and this shows us that integers are not reference types. They're actually called primitive types. In the last video, we had demonstrated why strings are reference types. Let's print a minus b. Print a minus b. What do you think will be printed to the console? Do you remember a was updated to 4? So 4 minus 3 is equal to 1. Let's create two more variables. Var c is equal to 4. Var d is equal to 5. But this time, let's be a little more descriptive with our print statements. Print the product of c and d is c multiplied by d. And we're going to use string interpolation to achieve this. The only thing that is new in the above line of code is the curly braces. If we are using interpolation and we want to perform an operation on the variable placeholder, we can put the placeholder in two curly braces and then perform the operation. Let's do the same thing for division. So we're going to print c divided by d is followed by the operation. The modulus refers to the remainder when we divide one number by another. We use the percent symbol when we want to calculate the modulus. Print the remainder when d is divided by c is d modulus c. Let's add some comments to make our code readable. Equality operators involve the double equal sign, which actually means equals, and the not equal sign, which places an exclamation point before a single equal sign. Comparison of two variables usually results in a Boolean value. What do you think is going to be printed to the screen when we say c equals d? Does that evaluate as true or false? What about c exclamation mark equal d or c not equal to d? The first one should evaluate as false, and the second one should evaluate as true. Relational operators involve the less than or equal to, less than, more than or equal to signs. Let's use some numbers. We're going to say 4 less than or equal to 5. What do you think this evaluates to? True. 4 more than or equal to 5. False. What about 4 more than 5? False. What about 4 less than 5? True. In the next video, we will be looking at if-else conditional statements and logical operators. If-else and logical operators. In this video, we're going to create if else, and else if statements and use logical operators with our if statements. If statements should be in every programmer's toolbox. They are used to execute code if a condition is true. We use the if keyword followed by parentheses. A condition is placed in the parentheses. If it evaluates as true, the code in curly braces will be executed. Obviously, if it is false, it will not be executed. Let's create some variables. Int favorite number is equal to 9. To begin an if statement, we start with if. If favorite number is equals 9, print the numbers are equal. The statement is printed because the condition evaluates to true. We can even use a Boolean for the condition. And this will always print because it's true. What do you think will be printed to the screen if it evaluated as false? If we used false, it would never print. If statements are usually accompanied with an else clause. So if the first is not true, the else clause will be executed. Create two variables. Var x is equal to 10. Var y is equal to 20. What do you think will be printed to the screen when we run this code? It is possible to perform multiple checks by using else if. You can have a million else if clauses, but the clause where the first condition evaluates as true will be executed. Logical operators involve the double ampersand, which means and, the double pipe sign, which means or, and the exclamation mark, which means not. If you have two or more conditions that you would like to have checked, you can use these logical operators. If you had a quiz app and you required the user to enter an even number that was less than 10, you would do something like this. Let's try answer is equal to 8 and run the program. Look carefully at this highlighted line, and you will notice that there are two conditions, each placed in a pair of parentheses and separated by two ampersand symbols. Then, the entire expression is contained in another pair of parentheses. To add comments to a block of code, select the code and hit Ctrl// on Windows or Command// on Mac. To uncomment, just type these combinations again once the code is highlighted. What if your quiz wanted a number that was divisible by 3 or not divisible by 6? Only one of these conditions needs to be true for the code to be executed. Let's try 6 and run the app. In the next video, we'll be looking at for loops, do while, and break. For loops, while, and do while. In this video, we will be looking at for loops, while, and do while. For loops are also conditional statements, and you can use for loops when you want to execute a line of code multiple times. To start a for loop, we begin with the keyword for. Then we open parentheses. We create a variable to store the counter. We create a condition. We increase the counter. Then we place the code we want executed between curly braces. Let's create a for loop to print Dart is cool 5 times. We have the counter variable I, which is an integer, the condition I less than 5, and the increment I++, which is shorthand for increasing I by 1. Let's create another for loop, but this time we're going to use int instead of var. It really doesn't matter. We will set I to 1 because it doesn't have to begin at 0. We will set the condition as I less than or equal to 7, and we're going to increase the counter variable by 1. Notice that there are semicolons between the counter variable, the condition, and the increment. We then place the code we want executed between two curly braces. While loops will continue to execute code once the condition is true. It can also cause an infinite loop that may cause your program to crash if you are careless with its implementation. Create a variable a and set the value to 1. The condition is a less than 10 or 1 less than 10, and this condition is always going to be true. This is going to print, this is an infinite loop to the screen, meaning that code is executed over and over. If we type break under the print statement and run the app again, the code is only executed once, and then it breaks out of the loop. In do while loops, the code runs once before it is actually evaluated. We can also have an infinite loop if we are careless with its implementation. In the do clause, let's print, I am going to be an excellent mobile app developer, and the condition is going to be less than 10, which always evaluates as true. Let's add a break statement and run the code again, and it only runs once. Let's change the condition to true and comment out the break statement, and once again we get an infinite loop. Let's change the condition to false, and it only runs once. Which one of these conditional statements would you use to print the 2 times table? Do while, or the for loop? You can pause the video if you need more time, and as a challenge, you can attempt to do this. We'll use the for loop to print the 2 times table up to 1000. This challenge incorporates everything that you have learned. What this code does is it loops through the numbers from 0 to 1000. For each number, it is going to print 2 multiplied by the counter variable, and then we perform the calculation in curly braces. Since the counter variable increases by 1, the calculation is going to be different for each iteration. In the next video, we're going to be looking at switch statements. Switch statements. In this video, we're going to discuss how switch statements could be used in an app, create a few switch statements, and compare switch statements to if-else. Switch statements are similar to if statements. they can control the flow of a program. Switch statements can have a number of possible execution paths. These paths are known as cases. Before we get started with switch statements, I would like to show you a weather app prototype that I created with Sketch app for Mac OS. It's a great investment if you plan to be developing apps. You can also use Photoshop or Balsamic mockups if you are a Windows user. In the center of the prototype, there is a text widget that says "Walk with sunglasses." This widget can be controlled by a switch statement. Declare and initialize a string to store the description. Let's call it description and set it to sunny. Declare a string and call it advice. Begin with the switch keyword. We place the variable that we want to switch on in parentheses. The first case is going to be sunny, and we want to set advice to walk with sunglasses. Then we're going to print advice, and we add the break keyword. Each non-empty clause must end with break. The second case is going to be rainy. We will set the advice to walk with an umbrella. The third case is going to be windy. We will set the advice to walk with a scarf. The fourth case is going to be snowing. We will set the advice to you'll need a winter jacket, gloves, boots, scarf, and a hat. The last case is going to be hot, and we will set the advice to break out the shorts. Each switch statement must have a default case. So if the weather is not sunny, rainy, snowing, hot, or windy, it's going to say weather data is unavailable. When we run the app with the description set to sunny, we get walk with sunglasses. When we run the app with the description set to rainy, we get walk with an umbrella. When we run the app with the description set to windy, we get walk with a scarf. When we change it to snowing, it says you'll need a winter jacket, gloves, boots, scarf, and a hat. When we run the app with the description set to hot, we get break out the shorts, and if we set the description to anything else, we're going to get weather data is unavailable. We're going to create another switch statement, but this time we're going to switch on integer values. For the first case, where position is 1, we're going to print you came first. For the second case, where position is 2, we're going to print you came second. For the third case, where position is 3, we're going to print you came third. The default case is going to print you didn't place. When we run the app, we get you didn't place because position is set to 0. If we set position to 1, we get you came first. If we set position to 2, we get you came second. If we set position to 3, we get you came third. You should use switch statements for fixed data values. Use if-else for variable conditions that result in a Boolean, and switch statements have better readability compared to if-else. Congratulations on making it to the end of section 2. You have covered a lot of ground in 2 days. In the next section, there will be an introduction to classes and objects. Object-oriented programming and data structures. Introduction to Classes and Objects. In this video, we are going to define a class, use a class to create an object, add properties to our class, and import the class we created. Object-oriented programming is a programming paradigm based on the concept that objects may contain information and be able to carry out functions. Dart is an example of an object-oriented programming language. A class is a blueprint for creating objects. Classes may have properties, and we use variables to store these properties. We call them instance variables. Classes may also have methods. Class names must begin with a capital letter, and objects are instances of classes. For this project, we're going to create a new Dart console application. So delete the default code, the import statement, as well as the code in parentheses. Place the word void before main. In the project window, expand your project and look for the lib folder. Right-click on the lib folder and create a directory. Call it classes. Right-click on the classes to create a Dart file. Call it computer. It is usually a best practice for class names to have the same name as the file name. We are going to use this file to create a computer object. I want you to stop what you're doing and take a look at the computer on your desk. Think about the properties that it has. It has a name, a certain amount of RAM, a CPU speed, and storage size. So let's give our computer object these properties. We would need some variables to store them. String brand, and we're going to set that to Apple. Int gigs of RAM, that's equal to 8. Double speed in gigahertz, that's equal to 2.7. Int storage space, that's equal to 128. I hope that you have noticed that my variable names are very descriptive. Return to main.dart. We need to import this class that we just created. So type import open and closing single quotes. Between these quotes, type package, introduction underscore to underscore classes underscore and underscore objects / classes / computers .dart. Now that we have our class, we are ready to start creating our objects. We can create an object and store it in a variable. An object is created using the new keyword. We can access the properties that we created using .syntax. We'll print the brand by using print, and inside of the print function, we're going to type mycomputer.brand. What do you think is going to happen if I change the brand from a lowercase apple, meaning apple starting with a common letter, to apple with a capital A? We can see that the property of our class gets updated. Let's try printing all of the other properties using .syntax. We can see that all of our properties have been displayed to the console. We can get the type of the object by using the runtime type function, which is a function that we can call on all objects in Dart. Return to computers.dart and let's create another class. We will call it phone, and this time we won't give it any properties. Return to main.dart and create a new phone object and store it in a variable called myPhone. Now let's use runtime type to get the type of this object. From the console's output, we can see that we have created a phone object. In the next video, we will be adding functions to our objects. Functions. In this video, we're going to define a function, create a function, and call a function. A function is a set of instructions that are executed when it is called. Functions have a name, and this is usually written in lower camel case. Functions can have no parameters, and if you look at the first example, there is nothing between the parentheses. The second example has one parameter and is usually some data type, such as a string, integer, double, or boolean. It can also be an object. The void keyword in both of these functions mean that they do not return a data value. In the next examples, we have two functions that each return a string. So we no longer use the void keyword. We use string instead, and we also see the use of the return keyword. The first function has no parameters, and the second function has two parameters. A method and function are basically the same thing, but the method belongs to a class. So a method can be called a function, but a function cannot be called a method. Open the last project we created and comment out these lines of code with a multi-line comment. We are going to first create a method with no parameter or return type. Let's call it sayGreeting, and don't forget your void keyword. We'll use the print function to print welcome to Dart 2 in 7 days. And yes, you can call a function inside another function, which is what we're doing. Go to the main function, which is a function, by the way, that we have been working with from day one, and try to call the method that we just created on the myComputer object from the last video. Seems like I forgot a semicolon. So let me fix that and let's try this again. Let's create another method with one parameter but no return type. Void sayHello2 and string your name is going to be the parameter. This method is going to print hello plus your name. Return to the main function and call this function on the myComputer object. When we call this function, we have to supply an argument. The argument is the data you pass into the method's parameters. In this case, our argument is going to be Victor. When we call it, we see Hello Victor printed to the screen. Return to the computer class and let's create a method with one parameter that returns an integer. If we try to access a outside the curly braces of this method, the compiler would complain. We're going to return a multiplied by 4. This return value can be stored in a variable. Return to main.dart and create a variable. Let's call it result1, and we're going to use this to store this value. Let's use 4 as the argument. 4 multiplied by 4 is 16. 16 should be printed to the console if we try to print result1. Return to computer.dart and let's create a method with two parameters that return an integer. Call it calculateSum, and this will take two integers. It is going to return the sum of A and B. Let's call this method on the myComputer object and use 4 and 3 as arguments. 4 plus 3 is equal to 7, so 7 should be printed in the console. Let's try calling one of these methods on the myPhone object that we created. What do you think is going to happen? It will not work because myPhone is not a computer object. However, if we copy one of the methods from the computer class and paste it in the phone class, we should now be able to call this method. In the next video, we will be looking at constructors, class inheritance, and overriding methods. Constructors, class inheritance, and overriding methods. In this video, we're going to use constructors to add properties to our objects, use inheritance to inherit properties and methods from other classes, and override a method from the parent class. Constructors allow us to set values whenever we are creating a new object. Constructors can be automatically generated by IntelliJ, and constructors have the same name as the class. Inheritance enables new objects to take on the properties of existing objects. You can create a class with similar properties and methods to the superclass. To inherit from a class, use the extends keyword. Overriding a method allows us to change the way it behaves. If an object from a parent class is used to invoke the method, then the version in the parent class will be executed. If an object of the subclass is used to invoke the method, then the version in the child will be executed. Let's create another Dart file in our classes folder and let's call it animals. Create a class named animals and let's give it some properties, but this time around, we're not going to set those properties. This time around, we're going to add a constructor by right-clicking in the class, select Generate, and choose Constructor. Make sure all of the properties are selected. Go to main.dart and create an animal object and store it in a variable called SumAnimal. In order to use this class in the main function, we need to import it. Now that we have a constructor, we can create an animal object and set the properties in one line of code. I will name this animal elephant. Set the number of legs to 4 and set the can fly property to false. Let's print these properties to the screen. If we try to create a computer object again, we would have to set all of these fields one by one, because we did not create a constructor for that class. In animal.dart, let's create another class and call it mammals. Mammals belong to the class of animals and should be able to inherit properties from the animal class. We can do this by using the extends keyword. When we try to extend the class, we get an error that says the superclass animal doesn't have a zero-argument constructor, so we need to create a constructor in this class that calls the super. Go to the main.dart and let's create a mammal object. We can store it in a variable called SumMammal, and we can print the properties of this mammal. We're only able to create this object and print these properties because mammal inherits from animal. Inheritance also works with methods. Let's create a method for the animal class. The method eat is going to print this animal eats food to the screen when it is called. Let's call it on the two objects that we created. We can call this method on the mammal class because the mammal class inherits from the animal class. What if we wanted to alter this method so that it behaves differently when it is called on a mammal object? We can achieve this by overriding the method. The section with super.eat is what we inherit from the parent class. If we leave it as it is, this method will execute the default behavior. But when we comment out super.eat and add print dogs eat meat and run the code again, the output is different. If we look at main.dart, we can see that the eat function is being called on two objects, but the output is different because the eat method has been overridden for the mammals class. In the next video, we'll be looking at interfaces and abstract classes. Interfaces and abstract classes. In this video, we're going to create an abstract class with abstract methods. Try to inherit from multiple classes and try to implement from multiple classes. In this slide, pretend that everything is a class. Ford, Mazda, Toyota, and Nissan are all cars. The Mazda, Toyota, and Nissan are imported vehicles. All four brands belong to the vehicle class. In Dart, multiple inheritance is not allowed. A class cannot inherit from more than one parent. Interfaces allow common functionality to unrelated classes. An interface enforces that a class implements a set list of public fields and methods. The keyword implement is followed by an existing named class whose public fields become implementation requirements for the current class. Abstract classes represent an idea. They have abstract methods, which are methods that do not have a body. Delete all the code in animal.dart. Let's create an abstract class and call it animal. Give it a Boolean property called vertebrate and an abstract method. You'll notice that this method has no curly braces or any code to be executed. Let's create another class called earAnimal and give it a method that will print this animal lives in the ear. Create another class called mammal. Give it two Boolean properties, covered in fur and has hair. Let's try to inherit from two classes by using the extends keyword. Create a class called bat and try to inherit from mammal. With one class, it works. Add a method to the mammal class. Call it breastfeed because it's one of the things that mammals do, and it will print this animal breastfeeds. Let's add a constructor to the mammal class. We need to create a constructor to the bat class that will call the super. If we add a comma after mammal and try to inherit another class, we get an error. We can only inherit from one class, but we can get implementation requirements from multiple classes. Let's replace extends with implements. We no longer need this constructor that calls the super, but we now have the ability to override the properties and methods of the mammal class. If we try to implement earAnimal, all we have to do is add the missing overrides. We can even implement the animal class and we get access to the properties, and we can provide our custom implementation of the method. In the next video, we will be looking at collections. These involve lists and maps. Introduction to collections, lists, and maps. In this video, we're going to create lists with various data types, create a map, and perform functions on lists and maps. In this tutorial, I will need to work with objects, so we'll need to create a class which will be a blueprint for our objects. We'll create a class called Parson with no properties or methods. This is the easiest way to create an object. A list is enclosed in a pair of square brackets. Each item in the list is separated by a comma. We can have a list of strings, a list of integers, a list of doubles, a list of booleans. We can also have a list of objects, but we first need to create these objects so that we can add them to the list. We'll create 4 person objects and place them in a list called people. In the main function, we want to print the first item, which would be at index 0. We must print strings, open square brackets, and place a 0 in the square brackets. This is called bracket notation. Let's do the same thing with integers, but this time let's print the value at index 1. Let's do the same thing with doubles, but this time let's print the value at index 3. Try the same thing with booleans. What about our list of people? Do you think the name of the object is going to be printed to the console? Instead, we get instance of person. To get the number or count of items in our list, we can use the .length method. How many items do we have in each of these lists? In each of these lists, we have 4 items. It's possible to remove the last item in a list by using the .removeLast method. This will return the value of the item that was removed. The last item in integers is 4. The last item in doubles is 4.4. The last item in booleans is false. The last item in people is going to be instance of person. We can also return a value at a specific index by using the removeAtIndex method. Each time we remove a value at a specific index, that value is going to be printed to the console. If we remove the value and try to print the list of strings, you will notice that one of the values is missing. We have house, cloud, and apple. The tree is missing because it was at index 0. We can also add values to a list using the .add method. The item that we add is added at the end of the list. We can create an empty list using new list, open angle brackets, string, followed by 2 empty parentheses and a semicolon, and we can store this in a variable. These lists are specific and can only hold the data type that is in the angled bracket. Let's add 2 person objects to empty list 4 and try to print empty list 4. What do you think is going to be printed to the console? Maps are similar to lists, but they are made up of key value pairs. Maps are contained in curly braces. Let's create some key value pairs where the key is a string and the value is also a string. We can use the .length method to return the number of key value pairs. We can use bracket notation and use the key to return the value. We can return all of the keys using the .keys method. And we can return all the values using the .values method. In the next video, we'll be using loops to iterate through collections. Using loops to iterate through collections. In this video, we're going to use a for loop to iterate through lists and use a for each loop to iterate through maps. We'll create a new project for this tutorial. Create a list of string values and let's fill it with items that we normally get at the grocery store. So let's add some eggs, bread, milk, cheese, and sugar. Print the first item of this list using bracket notation. The first item of this list is going to be at index 0. How would you go about printing all the items in this list? Would you try using the different index values? It seems like we are repeating ourselves, and as a programmer, that's never a good thing. We have broken the do not repeat yourself rule. When we do it this way, we may try to run code on an object that is out of bounds or not in range. We would only be able to use index 5 if there were 6 items in our list. We can comment out these lines of code using command and / on a Mac, or Control and / on a PC. We can use a for loop on a list to move through each item in a list. If there are 2 items in a list, list.length is going to return 2. When the code is run, it is executed on the initial value of I. Then I is increased, and the code runs again using a different value of I until it reaches the maximum value of I. Let's create another for loop, and this time we will convert all of the items in that loop to uppercase using the dot to uppercase method. List1 brackets I represents a single item in that list with an index value of I. Create an empty array and call it list2. We want to add items from list1 to list2. We can achieve this using a for loop. We're going to use the .add method. If we try to print list2, we can see that all items have been added. If we go a little bit further, we can shuffle the items in list2 and print the list. This would be useful if you were building a quiz and wanted to shuffle around the answers. Let's create a map, call it SumMap, and this map will have key value pairs comprising of integer as the key and string as the value. We can use a for each loop to iterate through lists and maps. We can execute code on each item in the map or list. The for each loop takes an anonymous function. An anonymous function is a function that has no name. If you look carefully, you can see the parentheses and the arguments inside the parentheses. The curly braces have been replaced by an equal sign and an angle bracket, and this is usually followed by a single line of code that we want executed. We will first use the for each loop to print the keys. You'll notice that I'm using K and V to represent the keys and values respectively, but we can use any letter or description that we prefer. Then we'll use it to print the values. I'll use the for loop again to print the keys, but this time I will use curly braces instead because I want it to resemble the functions that I introduced you to. We're going to loop through this map and add all the values to list 3. Then we're going to print list 3. Congratulations on making it to the end of day 3. You have covered a lot. In the next section, we'll start looking at Flutter and Material Design Widgets. Introduction to Material Design Widgets. Introduction to Material Design. In this video, we're going to define material design and look at the components that follow material guidelines. Material design is a design language that was developed in 2014 by Google. It allows us to build bold, beautiful products by uniting style branding, interaction, and motion under a consistent set of principles and components. It synthesizes the classic principles of good design with the innovation of technology and science. Create a new project and select Flutter. Type the project name, which should all be in lowercase, and use underscores for spaces. It is optional to give the project a description. Choose Java for Android and Swift for iOS, but it doesn't matter because you'll be writing code in Dart. When we first create a Flutter project, a default app is created. Run this app on the Android emulator by selecting Android SDK for x86. Both emulators were running before IntelliJ was started because they take a while to start up. Only the default Flutter app is running on Android. The beauty of developing apps on macOS is that you can develop for Android and iOS at the same time, and that in itself is a game changer. Run this app on the iOS simulator by selecting iPhone XS Max. In less than a minute, we have two apps running side by side for Android and iOS. If you click the floating action button or fab on each, you will see that the counter increases. If you want to build a great app, you need to follow the material design guidelines. Let's take a look at overview, and the first thing that we see is material theming. The default app that we looked at earlier came with a built-in baseline theme that can be used as is straight out of the proverbial box. If you want your app to stand out, you should add customization. You also have access to a material theme editor, which is a plugin for the Sketch app. Sketch is a great app for designers and developers, and it's $99 for a license. Since the default app only has a button, let's see if it adheres to material design guidelines. Buttons can be placed in dialogues, modal windows, forms, cards, toolbars. They should be identifiable, findable, and clear. There are different types of buttons. Buttons that are used for low emphasis, medium emphasis, and high emphasis. We even have toggle buttons. There are even examples of best practices and worst practices. For example, you shouldn't wrap text in a button. You should use capitalization for languages that allow capitalization. Let's take a look at the floating action button guidelines. The fab performs the primary or most common action on the screen. It appears in front of all screen content, typically as a circular shape with an icon in its center. If your primary action was composing email, a fab would be okay. You don't need them on every screen. You shouldn't have multiple fabs on screens, but you'll notice that Google Maps can get away with this because they're Google. A fab represents the primary action on a screen. A fab's action should be constructive, and it should be relevant to the screen on which it appears. The fab usually has a container and an icon, and the app's color scheme determines the fill that will be used in its container. When designing your fab icon, make sure it's not ambiguous, and don't place text in a regular fab. Individual components such as cards cannot each have their own fab. Fabs should use primary positive actions and avoid using minor overflow, unclear, or destructive actions. From here, you can see that a lot of thought should go into app components if you want them to adhere to material guidelines. In the next video, we'll be looking at Flutter project structure. Flutter project structure. In this video, we are going to be discussing the structure of a Flutter project and build a Flutter app and deploy it on Android and iOS. We're going to begin with a new project. The first thing that I want you to do is expand your project and delete the test folder. We delete this because we won't be creating any widgets, nor will we be testing them. Delete all of the code except the import statement because this can be very intimidating for a beginner. Let's create our main function, which is the entry point for our app, and inside of this, we place another function called runApp. RunApp is going to take an instance of a material app widget as an argument, and it will inflate this widget and attach it to the screen. Think of widgets as objects. In order to create an object, we need a class. Classes have constructors that allow us to set the properties of our objects. We can set the home property of our material app to a widget that we will create next. We can start typing STLESS, which is a shortcut to generate the boilerplate code for a stateless widget. We'll name it home screen, and the error should go away. You'll notice that on line 14, we are returning an instance of container, and container is also a widget. If we try running this on the iPhone simulator, we get a blank screen because we don't have anything in our container. Let's remove the container and replace it with a scaffold widget. Inside of the scaffold widget, we're going to create an app bar widget which contains a title. The title accepts a text widget. We can say Dart2 in 7 days and we can set the background color. This app bar widget looks a lot like a constructor. The reason for this is that there is an app bar class. If we run this on the iPhone, we can see that we have an app bar with all of the properties that we specified. If we run it on the Android emulator, we get the same thing, but our title is not centered. Return to IntelliJ and add a center title property to our widget. You can find out more about each property by reading the documentation. As a developer, it's a good practice to organize your code in folders and separate files when you can. Cut all of the code in our stateless widget and place it in a separate file called home screen, which will be placed in a folder called UI, which we will place in the lib folder. Do not forget to import material. Go to main.dart and import this class. Return to homescreen.dart and let's add a body to our scaffold. This body will have a container widget. Set the alignment to alignment.center. We can place another widget inside of our container using the child property. Our child is going to be a raised button. We're going to create an anonymous function that prints Dart2 is fun to the console when the button is pressed. This raised button will also have a child, and that child is going to be a text widget. We'll set the text to Dart2 is fun and add some styling. The style also takes a text style widget, which allows us to set the font size. Let's set the color of our button and set the color of our button text. Now let's run the app on Android. When we click the button, we see Dart2 is fun being printed to the console. Let's run it on iOS as well, and when we click the button, we see Dart2 is fun being printed to the console. So this is my take on Flutter project structure. We have our import statements, then we have our main widget, which may be stateless or stateful. We have our container widgets, and then smaller widgets such as image, text, and buttons. In the next video, we'll be looking at stateless and stateful widgets. Stateless Widgets Part 1. In this video, we will define a stateless widget, add images, add custom fonts to an app, and create a login page for an app. Stateless widgets are widgets that have no internal state to manage. Icons, icon buttons, and text are examples of stateless widgets. This is what your screen should look like by the end of Part 2. We're going to start with a new project, delete all of the code, but leave the material import statement. Create a directory in the root folder for our font and also create one for our images. Drag the Chalk Duster font file into the Fonts folder and hit OK. Drag the background image into the Images folder and hit OK. We need to add these assets to pubspec.yaml before we can use them. Let's add the font to our pubspec file. On line 33, there's one tab space before Fonts. On line 34, it's tab dash space family :space Chalk Duster. On line 35, 2 tabs Fonts : On line 36, 2 tabs dash space asset : space fonts / chalkduster.ttf. Under Uses Material Design, type assets : and hit enter. Dash space images / background.jpg and then hit packages.get. If there are any deviations from the way I type this, your app will not work. In main.dart, let's create the main method. Add the runApp function and pass in a material app. Let's add a home property and create a new home screen, which is a class that we will create next. Type st and select stateless and hit enter. Name your class home screen and the error should go away. Return a scaffold instead of a container. And in the body property, let's add a stack widget. This allows us to place widgets on top of each other. A stack can have children widgets, and we want to stack everything on top of our background image. Let's first add a widget for image assets. We first pass in a string that references the location of our image. For the fit, we'll choose boxFit.cover. For the height, double.infinity, and for the width, double.infinity. We can add an alignment property that will center the image. If we run this app on the iPhone simulator, we can see that image covers the full screen, but we can't see the status bar. We also have a debug banner going across the top. In our main function, let's set debug show check mode banner to false, and we need to import Flutter services. In our build function, we need to set our system overlay style to light. Let's run the app on both devices. Return to main.dart and let's add a container widget. Some widgets can have one child and others can have children. This container widget is going to be stacked on top of the image widget. Container widgets can only have one child. And add a column widget. Set the main axis alignment of the column to center. Let's add a padding widget to add space between our widgets. Let's create a text widget. The text is going to be Teacher's Corner. The \n allows the succeeding text to go on a new line. Let's style this text. We want the text to be aligned in the center. Set the font size to 36 and the font weight to 500. Set the font family to Chalk Duster and set the color to colors.green. Run the app and we can see that the font has been applied to our text widget. In the next video, we will look at more stateless widgets as we continue to build our login page. Stateless Widgets Part 2. In this video, we are going to complete our login page. We will be working with padding, row, outline button, text, and inkwell widgets. Then we will deploy the app on both platforms. We're going to be continuing from the last video. Let's copy the padding and paste it below the text widget. Copy the text widget and paste it below the padding widget. Set the text to an app for teachers to meet and share resources. Change the font family to Roboto. Remove the font weight and change the text color to white. Run the app on the Android emulator. Add padding under the text widget, but this time change the edge insets to 60. Let's create a row widget so that we can place our buttons side by side. Choose main axis alignment dot space evenly so that the buttons are evenly spaced. You'll notice that we don't have to use the new keyword anymore with this latest version of Flutter. We'll use outline buttons for sign up and sign in. Set the color of the text to white. Set the font size to 20. Add padding to the button. You'll notice the constant keyword, but this can actually be left out. Having it there just means that the padding is immutable and will not change at runtime. Set the value of edge insets to 5. Let's give the button a rounded rectangle border and make it circular and set the radius to 10. In the onPressed, we're going to have an anonymous function that will print sign up pressed to the console. To add the next button, just copy the first button and paste it below. Change sign up to sign in and change sign up pressed to sign in pressed. Let's run the app on the iPhone simulator. Let's add more padding outside of the row and create an inkwell. An inkwell is an alternative to a button. If you wanted to make a widget clickable, you could use an inkwell. When this is tapped, our anonymous function is going to print skip button pressed to the console. For the child, we're going to use a text widget that prints skip this for now. Set the font size to 18.0, set the font family to Roboto, and set the text color to white. Run it on the iPhone simulator and then run it on the Android simulator. If you were wondering how I knew which values to use for the padding and font size, they came from experimentation. It is very unlikely for a programmer to know all the properties of each Flutter widget. If you want to find out more, you can learn from reading the documentation. There is no shortcut. Finally, let's test these buttons. We can see that they're working because the text is being printed to the console. In the next video, we'll be looking at Stateful Widgets. Stateful Widgets Part 1. In this video, we're going to define stateful widgets, create another screen, use navigator.push to go to another screen, and build a form. If a widget changes, maybe due to the user interacting with it, it is stateful. A widget state is made up of values that can change. For example, whether or not a checkbox has been checked. The widget state is stored in a state object. When the widget state changes, the state must call setState, which tells the framework to redraw the widget. By the end of Part 2, this is what you will have. We will attach another screen to our login app. We will be able to enter a username and an email address. When we hit the reset field, it will clear all the information that we entered. We're going to be building on what we covered in the last video. Click on the lib folder and create a directory called UI. Click on the UI folder and create a Dart file and name it create_profile. In this file, import the material library. Create a stateful widget and name it create_profile. Return to main.dart and import this file by typing /UI followed by the file name. In the onPress for the sign up button, we're going to use navigator.push to go to our next screen. More details on navigator.push can be found on the Flutter website, and you can copy it direct and just substitute the name of the screen you want to push to. The navigator.push method will add a route to the stack of routes managed by the navigator. In the create profile file, return a scaffold instead of a container. Add an app bar and a title. Set the title to create a profile and set the background color to deep purple. Run the app on the iPhone simulator, and when we click the sign up button, we have an app bar with a working back arrow. In the body, add a stack widget. The first widget that we want to add to this app is a form. This form will have a list view as a child. The list view will have two text form fields as children. For the keyboard type, choose text input type .text. For the decoration, choose input decoration, and for the hint text, select enter a username. For the label text, type username. One of the cool things about Flutter is that it is very easy to copy widgets. We'll copy another text form field, and for the hint text, we will type you@example.com. For the label text, we will set that to email address. Let's run the app. We can see that the text is too close to the edge of the screen and we need to add some padding. The use of the constant keyword in the content padding widget just means that these values are not going to change at runtime. If we run the app again, we can see that the text is not so close to the edge of the screen. In the next video, we'll finish our profile page by adding buttons that change the state of our text form fields. Stateful Widgets Part 2. In this video, we're going to continue working on our profile page, add a working button which resets all the fields in our form, and deploy the app to Android and iOS. Place a position widget inside of our stack widget, but outside of the form widget. Set the value of left to 5, right 5, and bottom 80. Add a row widget as a child. Set the main axis alignment to space evenly, and we're going to add 2 raised button widgets as children. The child of raised button is going to be a text widget. Set the text to submit. Set the color to white. Set the font size to 20. Add padding and set the edge insets .all to 5.0. Set the color to colors.deep_purple. Copy the shape of the outlined button from main.dart and paste it under color. Copy the onPress method from the outline buttons as well, but we'll change the print message to submit button pressed. For the next button, just copy and paste the button that we just created. In our onPressed anonymous function, we're going to call setState. Scroll to the top of our create profile state class and let's create some variables to hold our controllers. If you read up on the text form field, one of the properties is a controller. We can use this controller to manipulate the contents of the text form field. The final keyword is used because any subclass of a stateful widget must be immutable and all fields must be final. They can't be changed. Let's create user controller and email controller. Private fields begin with an underscore. Add the controller to each text form field that we created. Set the first one to user controller and the second one to email controller. In our setState method, type userController.clear and emailController.clear. Change the text of the second button to reset. Change the color to red and run the app. It seems to work okay on the iPhone. Let's see if everything is okay on the Android device. It seems like we have a problem. The software keyboard causes our buttons to move. If we use the software keyboard on iOS, we get the same problem. After performing a Google search, I found that you can use the resize to avoid bottom padding property. This will be placed in our scaffold. As a programmer, be prepared to run into a lot of problems. Google will become your best friend when it's time to solve these problems. Let's run the app on both devices and see if we were successful in solving our problem. When we run the app on both devices, we can see that the problems have been solved. Congratulations on making it to the end of day 4. We have covered a lot. In the next section, we will be using HTTP and JSON. Parsing JSON objects. Using HTTP and JSON in our app. In this video, we're going to define JSON, HTTP, and API. Then we're going to sign up for an API key from newsapi.org. JSON stands for JavaScript Object Notation. It is used to transmit data between a server and a web application. JSON objects are enclosed with curly braces. They're made up of key-value pairs. Keys can be strings and values can be another string, number, object, list, boolean, or even null. Key-value pairs are separated by a comma. A colon separates each key and value. HTTP stands for Hypertext Transfer Protocol, and it is designed to enable communications between clients and servers. It works as a request-response protocol between a client and a server. The app that we are going to build is going to make an HTTP request to the server, and we're going to get back a JSON response. API stands for Application Program Interface. It sits between two applications and it allows them to talk to each other. APIs can work across different platforms. We need to go to newsapi.org and sign up for a free API key. Most API keys are free to test for developers. This is newsapi.org, and this is where you will get your JSON data from. The section outlined in red represents our JSON data. When we make the request, our application is going to receive this data. The section outlined in green represents a special URL that contains our API key. It is used to tell the server the number of requests that we are making. There are different URLs for each news source. If we look at the Pricing tab, we can see that the developer account is free, but business and enterprise accounts are fairly expensive. With the developer account, you get 1,000 requests per day. You get 250,000 requests per month with business and enterprise, and as you go over, you pay extra. I am going to log into my account. You can see my API key, and you can see from the graph that I have not made any requests as yet. If I need to upgrade my account, I would just need to log in and click Manage Subscription. At the end of this section, this is what your app should look like. It is going to take the data that it receives and place it on a card widget. When we click on the card, we're going to display an alert which gives a brief description of the news article. When we go into the app drawer, we can choose our news provider. This app allows us to get articles about Apple and Bitcoin. Create a new project with IntelliJ and let's get started. Add a directory to the root folder and name it Images. Drag the background file into the Images folder and hit OK. Open the PubSpec file and type assets : immediately under uses material design. Go on a new line and type --images/background.jpg. Hit packages get and close the file. Before we begin, let's upgrade Flutter by typing Flutter upgrade in the IntelliJ terminal. Let's delete all of the default code and we will set up the project to receive JSON data. We will continue building this app in the next video. Setting up the project to receive JSON data. In this video, we're going to import libraries to help us work with JSON and continue working on our layout. We need to import Dart async, Dart convert, and the HTTP package. Dart async provides support for asynchronous programming with classes such as future and stream. In this app, we will be working with the future class. A future object represents a computation whose return value might not yet be available. When we make a request, we have to wait on a response. This response can be affected by your internet speed. Dart convert allows us to work with JSON, and it will allow us to convert a JSON object to a string. The HTTP package allows us to make HTTP requests. We're going to continue from the last tutorial, and we're going to start by adding the main function. Use runApp to inflate the material widget. Set the home property of the material app to home, which is a class that we haven't created yet, and set the debug show checked mode banner to false. Create a stateful widget and name it home. Import Dart async, Dart convert, and the HTTP package. In our container, we're going to return a stack widget. Set the fit property to stackFit.expand. The stack widget can hold multiple widgets, and the first widget is going to be an image asset. And we will set image to the background file that we imported and set the fit to boxFit.cover. The next widget will be our scaffold. The scaffold will contain an app bar and the title will be centered. The title will be a text widget and we will set this to news. For the style, we will set the font family to Times New Roman and set the elevation of the app bar to 3.0. This creates a shadow under the app bar. For the background color, set it to blue with an opacity of 0.5. This will make the app bar somewhat transparent. The default background color of the scaffold is white. This should be set to transparent because we want to be able to see the background image. Run this on the iPhone simulator. You should notice that the app bar is transparent and you should be able to make out the shadow under the app bar. Once you have signed into newsapi.org, you should be able to get your API key. Copy it and we will store it in a final string named API URL. We will create this under our import statements. The first one is going to be for Apple News, and the second one will be about Bitcoin news. Return to the website to copy the API URL for Bitcoin and paste it in our app. We need to create some variables to store the data that we are going to get from the API. If you examine the JSON structure, you will see that we have square brackets that indicate that the articles are made up of a list of objects. In the next video, we're going to try to get data from the API. Getting data from the API. In this video, we're going to create a function to return a list of data from the API, print the API data to the console, and continue building the app layout. We are going to continue from the last video. Let's create a list variable and make it private by using the underscore prefix. Call it provider1. Create another one and call it provider2. Create another private variable and name it provider. Let's create a future function below our class. The future function is going to return a list. We will call it fetchData and it's going to take a single string parameter called API URL, and we're going to make this an asynchronous function. On the first line of this function, we're going to create a variable to hold the HTTP response and call it response. We're going to set this equal to await http.get API URL. When we call the function, we will pass in our API key. This method needs to return a list, so we will use the Dart convert library to decode the JSON response. In order for this function to work in our project, we have to make the main method async. We'll take the provider1 variable and set it to the data that is returned when we pass API URL1 into our function. We'll do the same thing for provider2, but we will set that to the data returned from API URL2. We're going to set provider to be equal to provider1. Using a for loop, we're going to loop through all the data that was returned in the list and print the title of each list. When we run this, we're going to see all of the titles in the console. If we compare them to the website, we can see that the app has received information from the API. We next need to import the cached network image library. This allows you to show images from the internet and keep them in the cache directory. This library is useful because it has a progress indicator and it shows an error widget if it doesn't connect. To install it, we just have to add it in the pubspec file. However, I recommend that you use version 0.4.2, which was released on August 30th, 2018. This was the version that I found to be most stable at the time of recording this tutorial. Add it under Cupertino icons and hit Packages Get. Return to main and let's start working on the body of the app. We'll add a center widget, and this widget will contain a list view builder widget. The list view builder is used to build a list view. The data for the list view may come from an external source. It has an item count parameter, which determines the number of times the callback function in Item Builder will be called. A callback function is basically a function passed into another function as an argument. If there are 20 items in the list from the API, this will be called 20 times, and we will see 20 card widgets on the screen. In the next video, we will be displaying JSON data on the screen. Displaying the JSON data on screen, Part 1. In this video, we're going to add content to the card widget and start building an app drawer to switch between providers. We're going to start working on the card widget. The card will have a column widget as a child. Set the main axis size of the column to minimum, and let's start working on the children widgets. We need a list tile to hold our cached image, and we will need to import the cached image library. We can copy the import statement from the website, as we have already added the dependency in the pubspec file. We will set the cached image as the title. For the URL, we're going to reference URL to image from the JSON tree. If you take a look at the API website, you will see a URL to image key, which is what we will be referencing. The placeholder will be set to the circular progress indicator. The error widget will be set to icons.error. The subtitle will be set to the title of the article. To get access to this key, we pass in _provider, position in bracket notation, title in bracket notation. We can add custom styling and set the font size to 16, font weight to W500, and the font family to Times New Roman. If we run the app, we can see that the circular progress indicator looks more like an oval because a height and width were not specified. But the app works and we can see images and the title. Let's add a drawer widget to the scaffold, and we will use this drawer to switch between news providers. The drawer will have a child, which will be a list view. The list view will accept multiple children widgets. The first widget is going to be a drawer header. The header takes a single widget, and we're going to use a text widget. Set the text to choose a news provider and add styling. Set the color of the text to white. Set the font family to Times New Roman, and set the text size to 18. Set the box decoration color to colors.blue. Let's run the app on the simulator, and you can see that the app drawer, when clicked, takes us into the drawer and displays the header that we created. Under the drawer header, let's add a list tile. Set the title to be a text widget, and set the text to be Apple News. Set the font family to Times New Roman, and set the font size to 18, and the font style to italic. Let's add an onTap property, which we will set to an anonymous function that prints Apple News selected to the console. When we run the app, and go into the app drawer and click on Apple News, we get Apple News selected being printed to the console. In the next video, we will add another news provider and continue building our app layout. Displaying the JSON data on screen, Part 2. In this video, we will add another list provider and replace the hard-coded string in the app bar's title. Let's add a subtitle to the list tile. Set the text to news articles mentioning Apple. For the style, set the font family to Times New Roman, set the font size to 16, and set the font style to italic. Run the app to see how it looks. Open the app drawer and take a look at the first drawer item. The next thing that we need to do is add another list tile for the other news provider. All we need to do is copy the previous list tile and make minor changes to the text. So we will change the title text, the subtitle text, and the text in the anonymous function. Run the app to see if the untap functions are working. If we look in the console, we can see Apple News selected and Bitcoin News selected. Let's create a private variable to store the headline text and set it to Apple News. We want the title text in the app bar to correspond to the selected news provider. In the first list tile, let's remove debug print. We're going to set provider to provider 1, and we're going to set headlines to be Apple News. We are attempting to change the state of our app. This means that we should use the setState function, but I want you to see what happens when we don't call setState. Let's do the same thing for the second list tile, but this time we're going to call setState and we're going to set the headlines to Bitcoin News and set provider to provider 2. Let's go to the app bar widget and rather than use a hard-coded string for the title text, set it to headlines. And use the toUpperCase method to convert the text to uppercase. Run the app on the simulator. Go into the app drawer and select Bitcoin News. Try changing it back to Apple News. Nothing happens. Return to the editor and add setState to the untap property of the Apple News list tile. Paste the code that was there before in the setState function and run the app. What do you think is going to happen? Clicking on Bitcoin News changes the provider to Bitcoin. Clicking on Apple News changes the provider back to Apple. We need to create a function that will show an alert. Name the function showNewsSnippet and make it private. This function will take 2 parameters, build context and a string. Build context is the context in which a widget is built. It allows the child widget to interact with the parent widget. The build context class allows us to get a handle to the location of a widget in the widget tree. We first need to create a variable to store the alert dialog. For the title property, we will set the text to headlines. Set the font size to 16. Set the font family to Times New Roman and the font weight to W500. For the content, let's set the text to be the snippet that we will pass into our function. Let's add a flat button to our actions. Set the text of the flat button to dismiss. Set the font size of this text to 16. Set the font family to Times New Roman and set the font style to italic. In the onPressed property, we're going to call an anonymous function that dismisses the alert. We're going to use navigator pop and pass context. In the next video, we will be wrapping up our project. Wrapping up. In this video, we're going to display an alert on the screen, tidy up our app by removing unnecessary code, and use the international package to format the current date and append it to the API key. We're going to continue from the last video. At the bottom of our function, we need to add the show dialog method that allows us to show the alert dialog by passing in the alert that we just created. In the card widgets untap property, we're going to pass the function that we created into an anonymous function. Anonymous functions seem to be popping up everywhere. Let's take a break from this app and let's take a look at functions that we are familiar with. The first function, named sum, returns a plus b. This function can be rewritten using one line of code. Instead of using return, we can use an equal sign, an angle bracket, and place the expression that we want returned on the right side. Can you now spot the similarities between an anonymous function and a regular function? If we pass the same arguments in both of these functions, what do you think the result is going to be? An anonymous function, simply put, is a function that has no name. Let's run the app on the simulator. When we click on the cards, we get a brief description of the news article. The app appears to be working fine, but there is one problem. Let's take a closer look at our API keys. The Apple News API key and the Bitcoin key contain a date. This means that the data is only valid for one day, and we need to find a way to update the news. The international package in Flutter allows us to format date strings. To add this dependency to our project, we just need to add a line of code to the pubspec file and add the import statement that will allow us to use this library in our project. Let's create a variable called now and set it to newDateTime.now. This gets the current date and time and stores it in this variable. Create another variable, call it formatter, and use it to store a new date format in the format year, month, and day. Create another variable, call it current date, and set it to formatter.format and pass in now. We can delete the for loop because we don't need it anymore. Let's try to print current date to the console by running the app. According to the Mac operating system, the date is the 21st of October 2018. If we look at the console, we can see the date is being displayed. Let's place this code outside of the main function because we want current date to be accessible by our API key. We're going to use string concatenation to add the current date to our string. This means that wherever a date occurs in the API key, it will be replaced by current date. Let's do this for the Apple API and run the app. We can see that the articles have changed. Let's do the same thing for the Bitcoin API. Go to the website and compare the articles to see if the app is updating. It seems like we have another problem because the website is displaying articles from the 20th. So it seems like the app is working better than the website. However, when we look at the Bitcoin articles, We can see that they're from the 21st, and they correspond to the articles being displayed in our app. Congratulations on making it to the end of day 5. In the next section, we will be looking at persistence in Flutter. Persisting data. Persistence in Flutter. Saving data with text files. In this video, we're going to define data persistence and look at different methods. We're going to build an app that stores data as text. Use the Flutter Toast library to add a toast message. Use Future Builder to paint a widget. Persisting data simply means saving it. The data survives after the process that has created it has ended. The data can be accessed at a later time. Data can be saved by using text files, shared preferences, or databases. We can visit the website for the Path Provider plugin to see how to use the app. If we click on the Install tab, there are instructions there on how to use it. We just need to add the dependency, run the Flutter get command, and add the import statement. We'll also use the Flutter Toast library to show a toast message on the screen. To add it to the app, we need to add the dependency and the import statement. We need the Dart async library because we need the app to work in the background. Instead of returning a container, let's return a scaffold. Add an app bar and set the title to Persisting Data Part 1. Add styling and set the font size to 20. Run the app on the phone to see how it looks. Let's go outside of our class and start creating the function that we need to get the local path. We're going to create a future function that returns a string. This function is going to be a getter, and we're going to name it underscore local path. In the body of the function, we're going to create a variable called directory and make it final. We're going to set it to await get application documents directory. We get access to this method when we import path provider. We're then going to return directory.path. We next need a method to get the file. This future function returns a file. This is also a getter, which means we can read data from this function. We use the underscore local path function to get the file path as a string and store it in a variable named path. We then append this path to the file name dartdemo.txt to get the complete path of the file. We take the file that was returned from the last file and store it in a final variable named file. The method .WriteAsString is used to write the string to a file. We next need to read data from the file. This future function can throw an error because we can have a case where there is no file to read. We have to place the code in a try-catch block. Rather than call write as string, we call read as string. That will allow us to get the path, create the file, and write and read to the file. Let's create a function that will allow us to toast a message if data has been entered. We can go to the Flutter Toast package website and copy the code snippet we want to use in our app. Let's choose Show Colored Toast and let's copy the code. Let's add a gravity property to show toast and set the toast gravity to bottom. Add a container widget to the body of the app and set the alignment to top center. Add a list tile as a child of the container widget. For the title property, add a column widget, and the column widget will contain children widgets. The first widget will be padding, and the edge insets will all be set to 12.0. Add a text widget that says your text will be displayed below. Set the font size to 16.0. Add a text field widget and name the controller text field. Create a variable named TextField to store a text editing controller object. In the decoration property, add input decoration and set the label text to enter some text. Copy and paste the padding widget below the TextField widget. Let's add a material button and set the minimum width to 280.0, the color to blue, and the text color to white. In the onPressed property, let's perform a check to see if the text field is empty. If it is empty, we want to show the error toast, and if it isn't, we will write the data in the text field to failed. For the child of the material button, let's add a text widget and set the text to save data. Let's go to the message property of show toast and set it to enter text. When we click the button, we get a toast message being displayed at the bottom of the screen. Add padding under the first text widget. We'll next add a future builder widget which calls a future function. As soon as the function completes, in this case, it is a read from file, the builder function is then executed. The builder function allows us to build a widget. The function contains a build context object called context and an async snapshot object. The async snapshot class is a representation of the most recent interaction with an asynchronous computation. We'll store the data from that computation in a variable called data. The data that we get back from the computation is going to be of type string. We'll next perform a check to see if the data exists. If the data is not null, we're going to return a text widget. We're going to populate the text widget with data from our variable and use the toString function to convert it to a string. Add styling and set the font size to 24.0. If no data has been entered, we will return a text widget that says the text you entered goes here. Make the main method asynchronous so that we can call our functions. Create a variable called data which stores the data after we have read it from the file. Perform a check to make sure the data is not null. Let's run the app, enter some text in the text field, and hit the Save Data button. The initial text is going to be no files to read because we need to stop the app and run it again to see if the data has persisted. We can see that it is successful because Dart2 in 7 days is displayed in the text widget. In the next video, we'll be saving data with shared preferences. Persistence in Flutter. Saving data with shared preferences. In this video, we're going to define shared preferences and build an app that persists data using shared preferences. For this app, we need the Shared Preferences plugin. This plugin wraps NS user defaults on iOS and shared preferences on Android for a persistent store of small pieces of simple data. It can only store data types such as int, double, bool, string, and string list. We need to add the dependency and the import statement. We need to create 2 functions. The first function is used to save data using shared preferences. This function is used to store the message that we enter into the text field. It has to be asynchronous. A shared preferences variable named preferences is created and is used to get access to an instance of shared preferences. Shared preferences stores data in key value pairs. The key is data and the value is message. We next need to create a function to load data using shared preferences. Like the previous method, we need to create a shared preferences variable which is used to get access to an instance of shared preferences. An if statement is used to check if the data is not null and if it is not empty. If it is empty, the message will be no data was saved. In order to load the data, we need to ensure that we call setState. In PubSpec, I have already added the dependencies on lines 22 and 23 for the shared preferences and Flutter tools. Return a scaffold instead of a container. Add an app bar to the scaffold. Give the app bar a title and add a text widget to the title, which we will set to Persisting Data Part 2. Run the app on the simulator. When building apps, make it a habit to test at regular intervals. Let's add a text editing controller object and store it in a variable named textField. This will allow us to manipulate the data that was added to the text editing controller. Create a private empty string. We need to override the initState method. Earlier, I had mentioned the To-Do tab of the editor. This shows you the location of all the to-do implementation tags. On line 25, we can see that we have a to-do tag. These are the two functions that we mentioned earlier. The one outlined in red is used to load the data that was saved using shared preferences, and the function in green is used to save the data using shared preferences. We need to ensure that the main method is async. In the body of our app, let's add a container widget. Set the alignment to top center. Add a list tile to the child widget. For the title, add a column. Add a padding widget to the column and set the edge insets to 12.0. Add a text widget to display the text. Your text will be displayed below. Set the font size to 16. Add more padding by copying and pasting the first padding widget. Add another text widget, and we're going to load the text that is stored in shared pref data. Set the font size of this text widget to 16 as well. Add more padding. Add a text field widget and set the controller to text field that we created earlier. For the decoration property, add input decoration and add label text. Set this label text to enter some text. Add more padding. Add a material button. Set the minimum width to 280.0. Set the color to blue. Set the text color to white. In the onPress, let's use an if-else statement to perform a check if the text field is empty and error toast will be shown. This method hasn't been created yet, so it will show an error. If the field isn't empty, save shared prefs will be called and it will save the text entered in the text field. The child will be a text widget and the text will be save data. We're going to use the Flutter Toast plugin to show a toast message and place it in a function called showErrorToast. Let's run this app on the simulator and try to save some text. We'll have to restart the app to see if it was saved. Nothing was saved. This means that somewhere in our program is an error. If it isn't loading the data, we need to check our function that loads the data. The load shared prefs function wasn't called in initState, so let's do that now. Let's run the app again and see what happens. We can see Dart2 in 7 days was stored. Let's add today's date and hit Save Data, and we can see that our data is being persisted. In the next video, we'll be saving data with databases. Persistence in Flutter. Saving data with databases Part 1. In this video, we're going to define a database, add the necessary libraries, set up the folder structure, and create the model for our database. By the end of this video, your database app should look similar to this. When you click on the fab, it takes you to a new screen that allows you to add student information. A database is a structured way of storing data in tables. Databases make data management easy. An example of a database would be phone contacts, your ISP using a database to manage clients, or an online encyclopedia. Relational databases store data in related tables. In this tutorial, we're going to be focusing on the model for our database. We first need to create a class that models the objects that you would like to save. If we create the model first, we will know which fields are needed for our table. We'll be using the SQFlight plugin. To use it, all we need to do is add the dependency and import the package. In the pubspec file, you can see that I have added the dependency for SQFlight and the path provider. We covered how to add dependencies in previous videos. Create a directory in the lib folder and call it model. Create another directory in the lib folder and call it UI. Create another directory in the lib folder and call it utils. In the model folder, create a Dart file named student. Let's create a class called student, which will model our object. We can begin by giving our class properties. These are sometimes called fields or member variables. We'll need string first name, string last name, string contact number, and int ID. All of these fields should be made private by using the underscore prefix. We next need to create a constructor which uses the first three fields only. We don't need an ID because the ID will be generated automatically whenever a student object is stored in the database. We need to use getters because these fields are private. Getters will allow us to read data from private fields. String get first name is going to return the contents of first name. String get last name is going to return the contents of last name. String get contact number is going to return the contents of contact number. We have to be able to map all of these fields into objects. Recall that a map is made up of key value pairs. We'll map first name to an object named first name. We'll map last name to an object named last name. We'll map contact number to an object named contact number. And we'll map ID to an object named ID. We next need to create a function that is going to return a map. The map is made up of a string and a dynamic object. This function is a way of linking the objects back to the fields. We must first create a map that is made up of a string value as the key, and the field will be the value. This is stored in a variable named map. First name will be linked to the field first name. Last name will be linked to the field last name. Contact number will be linked to the field contact number. We have to perform a check to make sure the ID is not null, and if it isn't, we return the map. Import material, and let's make the student class a stateless widget. Click on the red bulb to add the missing override. Let's return a container, and this container is going to determine the structure of the cards that will contain the data from the database. Set the margin to edgeinsets.all. Add a row as a child and set the cross-axis alignment to start. Add a column widget as one of the children and set the cross-axis alignment to start as well. This column widget will contain a text widget that displays the last name and first name of each student. The toUpperCase method was used to convert the last name to all caps. Set the color to black and the font size to 16.0. Set the font family to Roboto. Copy and paste another text widget and change the text to contact number. Change the font size to 14 and change the font style to italic. In the next video, we're going to be setting up our database client. Persistence in Flutter. Saving data with databases, Part 2. In this video, we're going to create a database helper class. Use the singleton approach so that there's only one instance of database helper being created. The database helper class creates the database and performs CRUD operations. These operations include create, read, update, and destroy. A singleton pattern is a software design pattern that restricts the instantiation of a class to one object. Do you remember when we wanted to create multiple person objects? Rather than being able to create multiple objects, we can only create one. Multiple database helper objects could use up valuable system resources. I have already created a file called database_helper and placed it in the folder named utils. These are the packages that we will need: SQFlight, Path Provider, Path, and Dart.io. The last two packages do not require any dependencies. Begin by creating a class named Database Helper. Let's create an instance of our database helper and store it in a private variable named instance. Make it static and final. Set it to new database helper.internal. The system will complain because we need to create a constructor named internal. .internal just means that it is an internal constructor and it will be restricted to the class. We need a factory constructor that will allow us to implement the singleton pattern. The factory constructor will return an instance of our database helper. We next need to create variables to store the name of the table as well as the name of the columns. All of these fields should be final. The name of the table is going to be student table and it's going to have 4 columns: ID, first name, last name, and contact number. We next need to create a static database object named DB and make it private. The advantage of creating a static variable is that it makes the program memory efficient. Let's create our first function, which is going to be a getter. If this function is successful, it is going to return a database. We use a getter because the static database variable is private. An if statement is used to check if the database is null. If it is not null, we return a database. We set DB to be the location of the database, which we are going to get from the function initDB. We have seen get application document directory in a previous tutorial when we were trying to get the location of a text file. This time, we use it to get the location of the database and store it in a variable named document directory. Create a variable named path and use the join method to join the location of the database to the name of our database. Let's call this database studentrecords.db instead of main.db. Let's store the database in a variable named OurDB. We're going to set this variable to open database and pass in the path, the version, and a method for the onCreate, which we will call onCreate. We next need to return our DB. The onCreate function is going to be a private function that has a database and an integer value as parameters. We're going to make it async. The function doesn't have to be called onCreate, but we're using that name because we're creating the database with this function. SQFlight is based on SQL databases, and SQL databases are created with commands that are represented by strings. These commands are usually typed in uppercase. We use the command createTable and pass in the table name. In parentheses, we add the column names. We have to describe the information that is going into these columns. Column ID is going to contain integer values and it's going to be the primary key. The first name column is going to contain text. The last name column is going to contain text. The contact number column is also going to contain text. We can now work on the functions that will allow us to manipulate our database. We need a function to insert data into our database. Whenever you insert data into a database, it returns an integer value. The first function is going to be futureType, which will return an integer if it is successful. Name the function SaveStudent and use the student object that we created as parameter. Import the library that we created so that we can use the student that we created earlier. For each of these database manipulation methods, we need to create an instance of the database client and store it in a variable named dbClient. We'll store the integer result in a variable named result and set it to await dbClient.insert, and we pass the student table as the first argument and student.toMap as the second function. Then we return the result. The next function will be a future function, which will return a list if it is successful. Name it getStudentRecords. Make this method async. We need an instance of the database client. We're going to perform a raw SQL query and save it in a variable named result. Call raw query on the DB client and pass in select asterisk from the student table. The asterisk represents all the data in the table. Call the toList function on the result to ensure that you are returning a list. In the next video, we will continue working on the database helper class. Persistence in Flutter. Saving data with databases, Part 3. In this video, we're going to continue working on our database helper class, create an object, and store it in the database. We need to create a function that retrieves a specific student from the database. This is going to be a future function, and it returns a student. Name this function getStudentRecord. It's going to require an ID as a parameter, and it's going to be async. Create an instance of the database client. Create a variable named result and perform a raw query on the database client. Pass in the string select asterisk from student table where column ID is equal to ID. This means that you select everything in the table that has the ID that we are looking for. Use an if statement to check if the length of the result is 0, and if it is, return null. If it's not, it will return a student object. Let's create a function that will return the number of items in the database. This function is going to be a future function that returns an integer if it is successful and is going to be async. Actually, all of these functions will be async. We need an instance of the database client. We're going to return sqflight.firstIntValue and pass in a query on the DB client. FirstIntValue is a helper method used to get the first int value in a query. We then perform a raw query on the database client and pass in selectCount asterisk from student table. We need to create a future function that will allow us to update student records. It will return an integer value if it is successful. This function is going to take a student object as a parameter. We'll need an instance of the database client. We'll use the update method on the database client and return it. This update method is a convenience method for updating rows in the database. It takes the name of the table as a string. It also takes a map of values such as student to map. For the parameter where, pass in the column ID is equal to question mark. For the parameter where args, pass in student ID in square brackets. We next need a function to allow us to delete items from the database. It is going to return an integer if it is successful. Name this function deleteRecord, and we're going to pass in the ID as a parameter. We need an instance of the database client. We're going to call the delete method on the database client and return it. The delete method is going to contain a string similar to the one used for the update method. We need one more function to close the database. It is going to be a future function, but it doesn't return anything. Name the function close and make it async. We need an instance of the database, and we are simply going to return dbClient.close. Go into the main method and add boilerplate code for a stateful widget. Name it home and return a scaffold. Add an app bar and set the title of this app bar to student records. In the main function, create an instance of database helper and import the class. Create an integer named saveStudent. Since we have to use await, ensure the main function is async. We're going to use the saveStudent method to save a student object. We need to import the student class. Let's use the print function to print the value of saveStudent to the console. We get a value of 2, and this value will increase each time we add an item to the database. Now that we know the database is working, delete the instance of the database, the student object, and the print statement. Also delete the Stateful Widget class. Set debug show checked mode banner to false. Create a stateless widget and name it home. Return a scaffold and add an app bar. Set the center tile to false. Set the text to student records. Set the font size to 24 and the font family to Roboto. Set the text color to white and the background color to purple. In our body, we're going to set it to a records class that we haven't created yet. Create a new Dart file named records in the UI folder. We'll need to import the material package. Create a stateful widget named records, and we want to return a scaffold. Let's add a purple floating action button that has a white add icon in the center. In the onPress, use navigator.push to go to another screen. This screen is called Entry, and we haven't created it as yet. Create a new Dart file in UI named Entry. Import the material package. Create a stateless widget named Entry. Go to records.dart and import the entry library. Go to main and import the records library. Run the app. When we click the fab, we are taken to the entry screen, which at this point is black. Go to entry.dart and return a scaffold. Add an app bar. Set the center tile property to false. Set the text to add student and add some styling. Run the app again. When we click on the fab, we are taken to the entry screen, which has a back icon in the app bar. In the body of the app, let's return a stack. Inside of the stack, let's add a form. This form will contain a list view. This form will contain a text field, which means that we need text editing controllers. We covered this on day 4. Text editing controllers are used to get a handle on text form fields. We need controllers for the first name, last name, and contact number. We also need an instance of the database, so we will need to import the database helper. In the next video, we will continue building the user interface. Persistence in Flutter. Saving data with databases, Part 4. In this video, we're going to continue working on the user interface. Set the controller of the first text form field to first name controller. Set the keyboard type to text input type.text. Set the decoration to input decoration. Add content padding with the edge insets set to all and set the value to 20. Set the label text to first name. Copy and paste the first name text form field to create the last name text form field and contact number text form field. Run the app to see how it looks. Create a positioned widget with the left set to 5.0, right 5.0, and bottom 80.0. Add a row widget as a child. Add a raised button inside a row widget. You can copy widgets from previous projects to speed up your workflow. Create a function at the bottom of the class named addInfo. It is going to take 3 parameters: first name, last name, and contact number. Make this method async. We want to clear all the text form fields when it is called. Create a student object and import the class. The student object is created using the parameters from our function. Create an integer named SaveStudent because the SaveStudent method returns an integer value. Call SaveStudent on the database instance and pass in the student object that we just created. Add a print statement that will print the ID of the SaveStudent when a student object is saved. Call addInfo in the onPress method and pass in firstNameController.text, lastNameController.text, contact number controller.text. Then use navigator.pop to return the records screen. Copy the raise button and paste it below the first one. Change the text to reset and change the color to red. In the onPress, clear all of the text fields. Run the app. Let's use the iOS keyboard. We seem to be running into a similar problem that we had on day 4. Open the project from day 4 and let's attempt to solve this problem. We need resize to avoid bottom padding, and we need to add that to our scaffold. When we run the app, we don't get the same problem as before, but when we scroll down to enter the contact number, the text fields are reset. This happens because we should have used a stateful widget. Also, there seems to be no way to dismiss the number pad for iOS. Change entry to a stateful widget. Run the app on Android to see if we have the same problem. When we switch between fields, the text doesn't disappear. When we hit Add Info, we can see that the item was added to the database. On iOS, the fields do not disappear, but there is no way to dismiss the number pad because the iOS number pad doesn't support this feature. The only way to exit will be to click on another field. Alternatively, we can change the text input type to text, and that could work. Now that we have the database up and running, we can remove the print statement. Go to records.dart and let's create an empty list of students and call it student records. Click on the red bulb to import the student class. Create an instance of the database helper and also import the database helper class. Override the initState method and call readDatabase, which is a method that we haven't created yet. Create this method at the bottom of our class. Create a list named StudentInfo and call getStudentRecords on the database. Use a for each loop to loop through all the items in the StudentInfo list. Use the FromMap function to map each field to an object. Make the student records list final and private. Call setState and add student.fromMap StudentInfo item to student records. Add a body to the scaffold. Add a column widget. Add a flexible widget to the column, which gives a child of column the flexibility to expand to fill the available space in the main axis. Add a list view builder as a child of the flexible. Set the reverse to false. Set the item count to studentRecords.length, and the item builder property will contain a callback function that returns a card widget. The card widget will contain a list tile as child, and the title will be an item from student records at a specific index. Run the app. You should be able to see the students that were added to the database. In the next video, we will work on updating and deleting items in the list view. Persistence in Flutter. Saving data with databases, Part 5. In this video, we are going to continue working on our user interface, pass data between different screens, and use the console to diagnose errors. Create a method called deleteStudent, which is going to take an integer value that represents the ID and another integer value that represents the index. Make it async and call deleteRecord on the database instance. Pass in the ID and then call setState. Then remove this item from the student records list at that particular index. Create another method named editStudent, and it will take a student and integer values as parameters. The student object will be set to a student object from the student records list at a particular index. Create a material page route that would allow us to pass data about a specific student to an edit page. This will appear as an error because it hasn't been created as yet. Create a Dart file named edit in the folder named UI and import material. The edit screen is going to be similar to the entry screen. Create a stateful widget and name it edit. At the top of the class, declare a student object. Create a constructor, which is basically saying that each edit object requires a student object, or each edit widget requires a student object. That student is going to be pushed from the editStudent method in the records class. Return to records and import the edit class. We can copy the text editing controller variables from the entry class as the database instance. Override the initState method. This method is called when the object is inserted into the tree. To use the student object that was pushed, place widget before student. The text editing controllers allow us to get a handle on the text editing fields. We can set the first name, last name, and contact number of these fields. I'm going to take a shortcut and copy the entire scaffold from entry.dart and paste it in edit.dart. We only need one raised button. Change the title of the app bar to Update Student. Change the text of the button to Update Info. Create a method to update the student record at the bottom of the class. It will require a first name, last name, and contact number. This method should be async. Create a variable named student and set it to student from map. We're going to type the names of the table names and map them to the variables in our method. The ID will have the same value as widget.student.id. Call update records on the database and pass in the student. Call the update student record in the onPressed of the update info button. The arguments are going to be first name controller.text, last name controller.text, and contact number controller.text. We're going to use navigator.pop and push named to go back to the main screen. If we use navigator.pop, the data will only be reloaded after we restart the app. We pass context and the name of our route is /home and it's a string. Go to the main function and under the home property of material app, we need to add a property for routes. Return to records.dart and let's add an onLongPressed property. And when the card is selected, we're going to call edit student on a specific student from the student's record list at the selected index. For the trailing property, add a listener. The key is going to be the first name of a student object at a particular index. We'll add a remove circle icon as a child and set the color to red. For the pointer down property, we call delete student and we pass in the student ID at that particular index. Copy the navigator.pop and push to home and paste it in entry.dart in the onPressed method of the add info button. Run the app and let's see if we can delete some of these items. The delete button appears to be working. Let's see if we can edit some of these items. Update doesn't seem to be working, so we need to fix this. Let's see if we can add students. This appears to be working. If we look at the console logs, we can see that there's a problem with the update records method in the database helper class. String interpolation should have been used for student table and column ID. Run the app after you have made the corrections. Let's edit doc mix stuffing. We can see that the entry has been updated. Let's update Susan's last name to Martin. Let's update Edward Nigma's phone number. This time, let's use the software keyboard. It seems like we have no other problems and the app is working fine. Congratulations on making it to the end of day 6. We've covered a lot and you can add Flutter databases to your programming utility belt. In the next section, we will be deploying your app to the Google Play Store and Apple App Stores. Deploying your app to the Google Play Store and Apple App Store. Deploying your app to the Google Play Store, Part 1. In this video, we're going to discuss the final state of the app, create a developer account, create a privacy policy, and create feature graphics and icons for your app. I have deployed the app on 3 virtual devices and tested it on my Android phone. I removed the Fab button because it was covering the trash can icon. I also removed all buttons from the positioned widget. When you long press on a card, you're taken to the update screen. All of the fields are populated with the data that you may want to change. When you are finished, you click the Done icon in the top right-hand corner. One cool thing about this app is that it supports landscape orientation. To push our app to the Google Play Store, we need to log into the Google Play console and create a developer account. It's a one-time fee of $25 US. You sign in with your Google account, and there are 4 steps. After you sign in, you accept the agreement, then you pay the registration fee, which requires a credit card. If you're really serious about becoming a mobile developer, this is a good investment. Once that is completed, you add your account details. We next need to get a privacy policy. We can generate one from termsfeed.com. Privacy policies are now required by law. Failing to have one can get your app removed from the App Store. Choose a language and choose a platform. Type in the name of your mobile app on the next page. Choose individual for entity type. Enter your country and go to the next step. Since we're going to be collecting information about students, we need to select all of these boxes. We will not be sending email to users. Neither will we be collecting location information. We will not be asking users to pay for products or services. We will not be using tracking tools such as Google Analytics. We will not be showing ads. There will be no ads on the mobile page. We will not use remarketing services because the good ones cost money. We will not be disclosing information to law enforcement agents because there is no information to disclose. We will not be selling this app. We don't need GDPR wording or CalOPA wording. Users can contact me with questions regarding the policy via email. Enter an email address so that you can receive the privacy policy and hit generate. Copy the link to your privacy policy and then add this to the privacy policy section of store listings. You get to this page after you create your app in the Play console. If you scroll up, you can see that there are a few graphics that need to be uploaded before we can add our app. We need a high-res icon, a feature graphic, promo graphic, TV banner, and don't worry about the Daydream 360. If you don't have Photoshop, you can use this free online feature graphic generator to make a feature graphic. It's very straightforward, and this is where I recommend that you team up with a designer, especially if you're not creative like me. There are other programs out there that you can use to generate these graphics, such as Inkscape and Box SVG. You can go to App Icon Generator to generate your icons. Just drag your icon into the area. We only need icons for iPhone, iPad, and Android. If you like the generator, you can buy the owner a coffee. The file that we downloaded contains 2 folders, one for Android and the other for iOS. Delete all the map folders from the res directory and replace them with the ones that we downloaded. If we go into the app drawer of our emulator, we can see that the app now uses the icon that we created. We can go to the Flutter website to get information on how to prepare an app for release. The first thing that we need to do is review the app manifest and remove permission to use the internet. We next need to review the build configuration. Go to the build.gradle file in the app folder. We can see the minimum SDK is 16, and this means you need Android 4.1 and up to run the app. We've already added the launcher icon, so we can skip that part. We next need to create a key store by running the following command in the terminal. You're going to run into problems if you don't have the Java Development Kit installed. Installation is quite straightforward. Just go to the website and download the version best suited for your machine. After installing the JDK, run the command again. You're asked to create a key store password. Write down this password so that you don't lose it. Then it asks you some personal information. You can migrate to the PKCS12 format by copying the command in quotes. It asks you for your password again. A new key is created and you are given the location. We next need to reference the key store from the app. We need to create a file named key.properties in the Android folder. In this folder, you will add the store password, the key password, the key alias, and the location of where the file is stored. We next need to configure the signing in Gradle. Copy the reference to the key store information and paste it above Android. Copy signing configs and build types and paste it over the section that contains build types. In the next video, we will continue working on releasing our app to the Google Play Store. Deploying your app to the Google Play Store, Part 2. In this video, we're going to configure ProGuard, generate an APK, and upload the app to Google Play Store. Copy these lines of code from the website. Create a file named ProGuard-rules.pro in the app folder. I have already created this file and added these lines of code. Go back to build.gradle and add these 3 lines of code to release in build types. We are now ready to generate a release APK. Run Flutter build APK space -- release, and the APK file will be generated in build/app/outputs/apk/release. This is the project folder. Click on Build, App, Outputs, APK. The app APK file is the one we will upload to the Play Store. In the Play console, let's go to App Release. Click on Manage in the production card. Select Create Release and click on Continue on the card that says App Signing by Google Play. Read the terms of service and hit Accept. You are then taken to a new screen that will allow you to add your APK file. The file is very small, only 5.19 megabytes. We need to enter release notes. You can't release your app unless you have release notes. When this app is updated, if you made changes, you will place them in this section. After you hit Save, hit Review. Before we can roll out this app, we need to add content rating, pricing, and distribution. The content rating is just a questionnaire. It asks for your email address. You can then select the category that best describes your app. Our app is basically a productivity app. Click No for violence and No for sexuality. No for abusive language and No for controlled substances. Click No for age-restricted products or activities. Click No for all miscellaneous options. Your app is then given a rating, and you can apply this rating to your app. Next, go to Pricing and Distribution. Our app is going to be free, and we want it to be available to the rest of the world. Scroll to the bottom and save the draft. Click No for primarily child-directed. Our app doesn't contain ads. This app meets Android content guidelines. Click the US Export Laws checkbox. Save the draft, and we are now ready to publish. To publish, click on Manage Releases. Click Edit Release in the production card. Click Review and click Rollout Production and then hit Confirm. Click Create Release. If we go to the dashboard, we can see that student info is pending publication. If we fast forward a couple of hours, we can see that our app has been published. When you upload your app, you can get your friends to download it and provide feedback. In the next video, we will be deploying our app to the Apple App Store. Deploying your app to the Apple App Store, Part 1. In this video, we're going to join the Apple Developer Program, create an iOS certificate for your app, add a privacy policy for the app, and set the pricing for the app. You will need an Apple ID. This is the ID that you use to download apps from the App Store. The ID should be associated with your native country. So for example, if you live in Barbados, like me, when you connect to the App Store, you should see the Barbados flag. Apple uses the country that your credit card is associated with. This is what the app will look like. It is running on the iPhone X and the iPad Air. Portrait and landscape modes are both supported, although the notch on the iPhone X might get in the way. In your browser, go to developer.apple.com/programs and hit Enroll. Before you can start this process, you need to enable two-factor authentication on your Mac. After you click Enroll, you're required to enter your username and password. If you're like me, you'll get a warning that says your Apple ID needs to be updated. I'm not going to cover how to turn on two-factor authentication because that process is very straightforward. In this section of the video, you can see that the country is set to United States. It was very difficult for me to switch countries because I had unused credit. For the entity type, select Individual and hit Continue. You are taken to a page that asks you for personal information. Check the box to confirm that you have read the license agreement. The rest of the process is fairly straightforward, and I'm not going to go through that for security reasons. It took a couple of minutes for the payment to go through. We now need to sign in to Apple Store Connect. When you sign in, you're greeted with a Terms of Service agreement. Click the box after reading and hit Accept, and you're taken to App Store Connect. Click on My Apps and click the plus button to add a new app. It says you have no eligible bundle IDs for iOS apps and you will need to register for one. You are taken to a page called iOS Certificates. Click on the plus button to add a new certificate and select App ID. Click the plus icon in the right corner again. For the app ID, I'm going to set it to Student Info. For the bundle ID, I'm going to set it to com.pact.studentinfo. For the services, I'm going to use data protection and hit Continue. And then hit Register on the next page. We can now go back to App Store Connect and click on the plus icon to create a new app. Name the app Student Info, set the language to English. Select the bundle ID that we created and for the SKU, student_info_01. We have run into a problem. The name Student Info was already taken. I'm going to name it Student Info 2 and click Create. You're next taken to a page with information about your app. We created a privacy policy for the Android app using terms feed, and we should reuse that privacy policy for our iOS app. If we log into the Google Developer Console and go to Store Listing and scroll to the bottom, we can see a link to our privacy policy. Copy the URL and paste it in the privacy policy URL box. Add a subtitle and click Save. For pricing and availability, set it to free and click Save. In the next video, we will continue working on deploying our app to the App Store. Deploying your app to the Apple App Store, Part 2. In this video, we're going to build a project and push it to App Store Connect. I have the app opened in IntelliJ and I'm going to click on the Terminal tab. Alternatively, you could use a terminal window inside the app folder. Enter the command Flutter build iOS -- simulator. This is not the command found on the Flutter website, which is Flutter build iOS. When I use the latter command, IntelliJ sticks. The problem with this command is that it doesn't add the pod files to the project. Open the project folder and click on the iOS folder. Double-click on the workspace folder to open it in XCode. Let's add some icons to our project. These icons were generated when we used the online app icon maker. Simply drag this folder into your project assets and delete the folder that was there before. Rename the folder to app icon and delete the extra asset. Click on Runner, and if you examine the files to the left, you can see that we don't have our pod files. The bundle identifier should match the identifier on App Store Connect. Change the display name to Student Info. Set the version to 1 and set the build to 2. Select your team. You will need to sign in with your App Store ID. Click on Product and set the destination to generic iOS device. Ensure that the scheme is set to Runner and click on Archive when you are ready to build. The build fails because pod files are missing, which means that we need to return to IntelliJ. This time, we're going to run Flutter build iOS. If you look at the folders on the left, you can see the missing pods. Before we build, let's go into Build Settings and type Inference in the search box. Set the Swift 3 at Objective-C Inference to default. Clean the project. Let's try to create an archive again. This time, we are successful. Select the runner file that we just created and click Validate App. Use the defaults for the next screen and hit Next. Choose Automatically Manage Signing. When the process is finished, click Validate. When the validation is finished, click Done. When you're finished, click Distribute App, and we want to distribute it to the iOS App Store. Click Upload. We have to resign Runner. We also have to review runner.ipa content and click Upload. When the process is finished, hit Done and log into App Store Connect. You should see your app and it needs to be prepared for submission. This is a long and tedious process, and you need to upload screenshots for different Apple devices. You need to add promotional text, keywords, description, and create a website for your app. After completing this section, I can guarantee that you will appreciate working on a team. I have created all my screenshots, and it took some time. I don't own all of these devices, but I was able to simulate them with XCode. To create the screenshots, all you need to do is select the device and hit Command and S. This saves the screenshot to your desktop. I have added promotional text, keywords, an image, and a description. The last thing that I need to do is add a supporting website. Click on Build and select Build when done. I'm hosting the app on my website, codechamp.com. This site is hosted by WordPress. Now it sounds like I am telling you that you need to go and spend money, but you're really investing in your future. To add this page to my blog took less than 10 minutes. Let's return to App Store Connect and try to submit this app. We forgot to submit a rating. For all of these categories, select None and No because the app doesn't contain offensive material. When you're finished, hit Done. Save the changes and hit Submit for review. For export compliance, select No. For content rights, select No. And for advertising identifier, select No and hit Submit. In the next video, we will discuss reasons why your app might get rejected. Reasons why your app might get rejected. In this video, we're going to discuss how long it takes your app to be published to the App Store. Discuss reasons why your app could be rejected. Look at apps that could be created with the Flutter framework. Apple has a stricter approval process as compared to Google. Each app is subject to App Store guidelines. Guidelines focus on design, content, and functionality. It can take up to 2 days or longer, but 90% are reviewed within 48 hours. Your app may be rejected because it has bugs, has broken links, forgot to provide a username and password, especially if your app has a login page. The description can also be inaccurate. Your app may be rejected because it doesn't follow material guidelines, it doesn't use identifiers for advertisers, but displays ads. The app targets a very small niche of people, or the app doesn't have a privacy policy. Alibaba, Hamilton Musical, and Abbey Road Studios have apps that were created with the Flutter framework. Here is Alibaba running on my iPad in landscape mode. There is a search box at the top and 5 tabs to the bottom. On my Android phone, there are only 4 tabs to the bottom. I'm assuming that Alibaba is using media queries to resize the app. Here is Hamilton Musical running on Android. It also runs on iOS, but it is optimized for iPhone. This is somewhat similar to the news app that we built. I'm assuming the information contained from the cards is taken from their website through an API. Like I mentioned before, it is always good to have a website for your app. Abbey Road Studios have released an app named Top Line for Android and iOS. I can't show you the iOS version because it hasn't been made available to this region. I can show you the app working on my Android phone. This app records your voice and it can add an audio track. You can then save this track and export it. In my opinion, this is more versatile than Android's built-in sound recorder. If you go to the Flutter website, you can find more information about apps that were built with Flutter. In most cases, these apps will be available on the Android and iOS stores. You can install a few of them on your phone or tablet and test them out. Some of you might be thinking that you may only want to use native code. With Flutter, you build for one and deploy on two. With native, you build for one and deploy on one. So that is something you may want to consider. In the next video, we'll be talking about promoting your app and moving forward. Promoting your app and moving forward. In this video, we're going to discuss how to promote your app and talk about moving forward. You're going to have to put yourself out there. That is the only way that you will be discovered. You need to have a blog or website. You can go the free route and go to blogger.com and create your own blog for free. The only problem with this is that you will not have a custom domain. The blog is the best way to create a portfolio of your work and showcase your skills. When you have a blog, you are in full control of your website. YouTube is a great way to showcase your work and make some money in the process. I actually started out with YouTube because as a teacher in a primary school, I wanted to build an app that could send push notifications to parents. There was this third-party plugin called PushBots that I could use with Cordova. Cordova at the time was just like Flutter, where you could build for Android and iOS, but it wasn't as performant. My tutorial was so good that the creators of PushBots used it on their website. It had 1,000 views after a couple of months, and this inspired me to make more tutorials. Shortly afterwards, I started monetizing the videos and started to earn a few cents. YouTube isn't the best place, in my opinion, for programming tutorials, but it's the easiest and cheapest way to gain a following in the form of subscribers. When you're ready to produce an app or produce an online course, you already have a group of people who will be willing to support you. The key to YouTube is being consistent and producing meaningful content. You also need to have a GitHub account to share your code. When you're making your projects, you should share your code because it helps other new developers, it gains followers, and it puts you out there as well. When you start to work as a developer, you will do a lot of code sharing through GitHub, so it's best to learn all the shortcuts and the commands. Facebook is very good at promoting products through ads. This is my Facebook page for CodeChamp. We can share the app that we created on the Play Store through Facebook. We just need to add a description of the post. When you're done, you hit publish, but Facebook doesn't allow you to show off your coding skills as a developer. One thing I like about Facebook is the ability to boost posts through ads, and you can boost posts to certain demographics. I'll take an old post for example, and I can target men, women, or both living in a particular location. LinkedIn is great for getting discovered. You can upload your skills and get discovered by recruiters. Actually, that is how I was found. You can also search for programming jobs and create connections with other developers, and maybe you could work together on a project. As you develop your programming skills, you could join Stack Overflow and try to help other new developers by answering questions they may have. Also, if you have any questions about how to get something done with Flutter or Dart, you can search on Stack Overflow. Stack Overflow also has a section on remote jobs. You can click on the jobs that you are interested in. You can work from home. This can even be a second source of income. We have come to the end of the course. Thank you for your purchase, and I hope that you found it useful and it inspires you to build your next app using the Dart 2 Flutter framework.